All right, this is going on page 95. I redid these notes last minute yesterday, and then I forgot to change some stuff here. So we can mark off this and inequalities, because right now we're just looking at equations. But we're going to take all those rules that we learned yesterday and that we just reviewed yesterday, or today, and we're going to change them up a little bit, but not really change them up. I know that's what it's going to seem like to you. You may even think at some point, why the heck did we even do what we did yesterday? There is a time and place for that, and once we learn both processes here, we can understand better how to decipher between the two, okay? Okay, now, everybody focus. The first part up here says, consider the following two statements. So I have the sine of x equals 1/2, and sine inverse of 1/2 equals x. Okay, they're giving me two things. If I am given equation 1, then in order for me to get x by itself, I would have to take the sine inverse of both sides, which would then get me to this point right here. You agree with that? Take the sine inverse of both sides, equation 1 becomes equation 2. But are these two equivalent? And the answer is no. Okay, and I'm going to relate this to something that I think we pretty much understand already, and that is this. If I tell you that x equals the square root of 4, right, then that means that x equals 2. We all agree with that? But if I tell you that y squared equals 4, and we are solving for y, then I'm going to take the square root of both sides and get y equals plus or minus the square root of 4, which equals plus or minus 2. Okay? So I want you to think about that for a minute. Both of these situations have square root rules in them that we understand, right? But the rules are a little different depending on how it's presented to me, right? If I introduce the square root, I have to put a plus or minus. If the square root is already there, then that limits my possibilities. It's either just the positive, or if there was a negative in front of it, it would be just the negative. Does that make sense to you? So what we're doing today is different in a way from yesterday, as these two things are different than each other. Still really kind of doing the same thing, but it depends on how the original one was presented to you. So let me, my board's doing weird things. So let me explain that to you in terms of what we're doing over here with this down here. So on the unit circle, we know that there are two angles between 0 and 2 pi, so for one rotation, where the sine of theta equals 1/2. That happens here at pi 6. So right here at pi 6. And then right here at 5 pi 6. Right? There are two places where the sine of the angle gives me 1/2. Right? However, due to domain restrictions, sine inverse of 1/2 is pi 6 only, because we were restricted to that little piece. So if I'm looking at one lap around the unit circle, there are two places where the sine of the angle gives me 1/2, but when I have the sine inverse, I only get pi 6. All right. So as a result, when we are solving equations involving trigonometric functions, we must modify our solutions to account for any domain restrictions or lack of any domain restrictions. So if you're just straight up doing the inverse, what is the sine inverse of whatever? You have all the restrictions we talked about yesterday. When we are solving equations today and it's not given to us that way, but we end up taking the inverse, we're either going to be told a different set of restrictions or that there aren't any at all. Okay, and then we'll look at how to handle that. We okay so far? Sort of? All right, stick with me. You'll be okay, I promise. All right, so then we're going to be talking about finding general solutions. So let me back up to my picture one more time. I have an angle here at pi 6 and at 5 pi 6 that both give me a sine of 1/2. If I keep rotating around and I end up at 13 pi 6, then that's also going to give me 1/2. And this one will give me 1/2 again. And I can keep rotating around, and I could even rotate the other way, right? So there's actually an infinite amount of angles that would give me a sine value of 1/2. And that's what our general solutions are. That's basically what this says right here. Since they are periodic, we can have infinitely many solutions. Okay, not always, but we can if there's no domain restrictions. So since we knew all this, and sine is periodic with a period of 2 pi, we know that if it works at x equals pi 6, I do one more rotation of 2 pi and get to 13 pi 6. Or 5 pi 6, I add the 2 pi and get 17 pi 6. And I can keep adding or keep subtracting. Okay, just keep going around the circle. And I think that's what this is. Yeah, we can keep rotating around the circle as many times. And so we have to know how to express that because we cannot write out an infinite number of answers. So let's write those out for these three statements here. So I have the sine of x equals 1/2. What I can do is make this into an inverse. Israel, you with us? Somebody wake him up. Hey, wake up. All right. If sine of x equals 1/2, if I need to get x by itself, I'm going to take the sine inverse of both sides. Now I can write that. I'm going to write this step and then I'm going to erase it, so I wouldn't write it. But it would look just like this: x equals sine inverse of 1/2. Then it looks like what we did yesterday. But I made that step. It wasn't given to me like that. But we don't necessarily have to write it. And I think maybe not writing it would help you not get it confused with what we did yesterday. Because I think it might also help you make sense of what you're doing. This has to be an angle, right? So I'm asking myself, what angle gives me a sine value of 1/2, right? And then I am going to draw myself this little diagram here. I do this for myself too, not just for your benefit. You can look at my key because it's on there. This is a positive value. Sine is positive in the first and second quadrants. So I just put little dots there so I know where my information has to come from, all right? And then we've said it 1,000 times. So I know that pi 6 would give me 1/2. But I have to use every single angle that lands where pi 6 is. And since that would mean a rotation of 2 pi, I would add 2 pi k. And we did some domain and stuff like that with that before. Remember when we had to repeat it a bunch of times? And then that's from the first quadrant. And then the second quadrant, what's my second quadrant pi 6 angle? 5 pi 6. So 5 pi 6. And then I would also put plus 2 pi k. And then I would need to say where k is an integer. Okay? Because k can't be 2.5. It can be 2, it can be -2, but it's going to give me a full rotation either way. Okay? Now, remember, the restrictions we had for yesterday, those are put on a shelf for when we come back and do something exactly like that. But right now, we are taking the inverse, but our restrictions are different. Everybody okay so far? I think this part's going to make way more sense to you than yesterday did, but we can't forget about what we did yesterday. All right, so then cosine. Cosine's positive in which quadrants? 1 and 4. Okay. And then I ask myself, what angle gives me a cosine value of 1/2? Pi thirds. So I would put pi thirds plus 2 pi k. Then I also need my fourth quadrant pi thirds angle, but I'm not doing the negative stuff like yesterday. It's back to the ones we're used to. What is my fourth quadrant pi thirds angle? 5 pi thirds plus 2 pi k. Okay, where k is an integer. And don't get ahead of me on tangent. And I use k, College Board uses k, but that doesn't mean in some other context they wouldn't use n or something like that. As long as you identify what it is, it's really any variable. K and n are the most common ones for that. Everybody good so far? All right, so then we're going to look at tangent. Tangent is positive in which quadrants? 1 and 3, right? All right, so x equals, what angle gives me a tangent value of 1? Pi fourths. Okay, now before we write anything else, I could do pi fourths plus 2 pi k just like I was doing the other ones. Okay, there's nothing wrong with that, but that's not how you would see it if it was multiple choice, because instead of going all the way around, if I just go halfway, that's pi, I end up at the other angle. And I can add pi again, and I can add pi again, and I can add pi again. You see how that works? So I can really just do plus pi times k, and I don't have to do anything else. And you can remember that because 2 pi is your period for sine and cosine, pi is your period for tangent, right? And again, if you were writing it out and you put both of the angles and you put plus 2 pi k or plus pi k, it's not wrong, but this would most likely be a multiple choice that you'd have to match up. So we need to make sure that we understand how it works. Okay, we good? Yes? All right, and then so I still need to put where k is an integer. All right, any questions at this point? You need to do some jumping jacks back there? You need to stand up and do some jumping jacks? No. You need to? You can stand up and do something. All right, so this says find all the solutions to this equation, which means there's an infinite amount of them, right? This is a negative cosine value. Cosine is negative in which quadrants? Second and third, right? So my answers are going to come from the second and third quadrants. What angle in the first quadrant, we always go back to the reference angle, what angle gives me a cosine value of the square root of 2 over 2? Pi fourths, okay? So pi fourths from here, but I need what's my second quadrant pi fourths angle? 3 pi fourths. And then I need to put plus what? 2 pi k. And then x equals, what's my third quadrant? 5 pi fourths plus 2 pi k. Okay. Any questions about that? And that takes care of all infinite number of answers. Yes, ma'am. Oh, no, thank you for asking that. No, we wrote it on the front there. It really kind of is understood. So I'm not going to make you write it. If these were answer choices on a multiple choice, it may or may not say that part. But after we understand it, it's kind of understood. So that's a very good question. You don't have to write that. Anything else? Yes, ma'am. Yes, I put on here for myself, where is cosine negative? That way, once I figured out my pi fourths, I'd know what quadrants to get it from. Yeah. But you can do whatever you want. That's just what works for me, so I remember what to go back to. Anything else? Those are good questions. All right. So then we have sine of x equals -1. Well, the angle that gives me a sine value of -1, is that in a quadrant? No. How many times does it show up? Just once, right? And it's right here. It's a quadrantal because that ordered pair is 0, -1, right? So that means that x equals, what's that angle measure? 3 pi halves. And this says find all the solutions, and there's nothing else there. So I have to put plus 2 pi k. And in this instance, even though it's sine, I only have one to write because it only showed up once in one rotation. Okay. What questions you got? All right. Now, example 3. This does say find all the values of x, but then it gives me this. So there's not an infinite amount of answers. There's at most 2. And this is tangent. Tangent is positive in the first and what? Third. And that's not how we're used to seeing our numbers, but if we rationalize, then we'll be fine. So this becomes square root of 3 over 3. So then I ask myself, what angle gives me a tangent value of the square root of 3 over 3? Pi 6. And in the first quadrant, that is pi 6. There is no plus 2 pi k, because I only get to go from 0 to 2 pi. And then my third quadrant would be what? 7 pi 6. Okay. What questions do you have? Do you see the difference in the two answers and how they either tell you a restriction or they don't? And your restriction could really be anything. It can be from 0 to 2 pi. It could be from 0 to pi. It could be from pi halves to 2 pi. I think all I have seen from College Board is 0 to 2 pi, but just pay attention to that just in case. Okay. All right, so technically we've been solving them, but this says when we're solving trig equations, we need to isolate the function. So that just means like this sine of theta part right there. Find corresponding angle measures. This is the important part right here. Consider any domain restrictions. So don't forget about that, right? When I look at example 4, it says all values and there's no other restrictions. That tells me I'm going to have that plus 2 pi k thing in there. I'm going to rewrite that just because I think it's better. Plus, you're going to have to rewrite them because it's going to be on the computer anyway. Equals 3 squared root of 2. Now we're solving equations that got trig stuff in them. Don't start making up math. You know how to solve equations. You've been doing them forever. What would my first step be here? Divide by 6. Okay. So sine theta is equal to 3 squared root of 2 over 6. Can I simplify that? Yes. So sine of theta is equal to square root of 2 over 2. And then we're right back to where we were on those ones up there. Sine is positive in the first and second. So what angle gives me a sine value of the square root of 2 over 2? Pi 4. Do I need to put plus 2 pi k? Yes, plus 2 pi k. And then I need my second quadrant. What would that be? 3 pi 4 plus 2 pi k. What questions do you have? Anything? No question? Okay. Example 5. They give us f of x, they give us g of x, and then it says in the xy plane, what are the x coordinates of the points of intersection of the graph of f and g? So I need to set something up. What do I do to set this up? Set them what? Set them equal to each other, exactly. So I've got 3 plus 2 cosine x equals 2. So what would be the first thing I do? Subtract 3. So 2 times the cosine of x equals negative 1. Then what would I do? Divide by 2. Cosine of x is equal to negative 1/2. All right. Cosine is negative in which quadrants? Second and third. And this does not say all values. It says from 0 to 2 pi. So x here. So what first quadrant angle gives me a cosine value of 1/2? Pi thirds. Remember, you can still use your hand trick. So what is my second quadrant pi thirds angle? 2 pi thirds. Do I need the plus 2 pi k? No. Then my third quadrant would be what? 4 pi thirds. What questions do you have? Okay, so there is a second page to part 1 that takes us into some factoring and other things with these. We are going to do that tomorrow, but I'm going to give you your assignment today, but I don't want you going past number 8. I know some of y'all probably ain't going to do anything at all, but for those of you that actually do your stuff, you can get 1 through 8 done before tomorrow. That would probably be helpful. Don't even try to do anything past 8 because we need to talk about some things, all right?